So now we're going to take a look and see how we can, again, use some of the trigonometry concepts that we've learned to solve some application problems. Here we have a problem that says for a reverse bungee ride, so this is one of those rides where it like slingshots you up in the air and you bounce back and forth. It says Reagan, which I'm assuming is this person here, stands halfway between two vertical posts. Two bungee cords extend from the top of the post to Reagan's waist, and the waist of Reagan is 1 meter above the ground. How tall, with that information, plus it gives us another piece of information that these posts are 8 meters apart, how tall are the vertical posts? Okay, so what we're going to do here is we're going to notice that we're going to, well, first of all, we're going to kind of assume that when they say vertical posts, it means that they are perpendicular to the ground. So this post comes down here and makes a right angle. Now, if I complete a right triangle right here, I can look at that right triangle and realize that I know an angle measure in that right triangle, and I know a side length. I know that this angle here is 70, and then I know that this side is half of this 8, because it says Reagan is standing halfway between the two vertical posts. So let's put a measurement of 4 right down here. All right, so we got 4 for this length right here, 4 meters technically. What we can now do is use SOHCAHTOA. We haven't used that for a while, but we can use SOHCAHTOA to find this distance. And let's do that right now. Let's call that distance x. So I'll put an x on my picture right there. And I'll say that I'll first analyze and say, okay, here's my angle. That would be the opposite side from my angle, and this 4 that I know would be the adjacent side. And so that's pointing me towards using tangent. I could say that the tangent of the 70-degree angle would be x over 4. And if I cross multiply this, x would be 4 times tangent 70. And 4 tangent 70 is going to be about, let's see, that should round pretty much to 11 meters. It's like 10.9899. So we'll just go ahead and round that to 11 meters. Now that, of course, is not our answer, because why would they be giving us this piece of information right here? Because what we found at 11 meters is this point that's kind of horizontal from where the bungee cords are attaching. From there up to the top is 11 meters. But that point is actually 1 meter above the ground, because again, it's kind of going to Reagan's waist where the bungee cords are attached. So we have to add a meter to that. We need to say plus 1 meter, and our final answer would be 12 meters. So in this problem, we used a little bit of SOHCAHTOA to find our missing information. Let's look and see in this problem what we're going to need to use. It says Nadim sees the tour bus from the top of the tower. So we're assuming that this picture here has this representing the tower that Nadim is standing on right up at the top, looking down at the tour bus. And we can see this 23 degrees is her angle of depression. Angle of depression that we learned about in the last video. To the nearest foot, how far is the bus from the base of the tower? So this is a 23-degree angle looking down. This is 180 feet. I'm guessing that means from the ground up to where Nadim is standing at the top of the tower is 180 feet. And we want to find to the nearest foot how far is the bus from the base of the tower. So what part of that picture is that representing? Well, here's the bus. Here's the base of the tower. So it seems to me that the value we're trying to find is this right here. What is this distance? So I'll go ahead and label that as x. And so what can we do? Well, we can first assume that this tower is built straight up and down, so it's going to form a right angle. And that means we do have a right triangle that we might be able to work with right here. But at first it appears that the only thing we know about this right triangle is that one of its sides is 180. Of course, we want to know what its other leg length is. We know one leg, we want to know the other leg. But it doesn't at first seem like we know an angle that's inside this. Except for if we remember that idea that we talked about in the previous video, where this is a horizontal line, you know, like the eye line from horizontally coming out from where Nadim is standing. That would be completely horizontal, and we're going to assume this ground is horizontal too, that this bus is not parked somewhere down a hill from where the tower is. We'll just make that assumption. And if this and this are parallel, that means this 23-degree angle would be the same as this angle right here. So I'm going to go ahead and write 23 degrees there. And now I can see that I would be able to set up an equation that says the tangent of that 23-degree angle that's now inside my triangle here would be equal to opposite over adjacent, 180 over x. And if I cross multiply this, I'm going to end up with x times tangent 23 equals 180. And now I would divide both sides by tangent 23. So x is equal to 180 divided by tangent 23, which we'll type in our calculator and get approximately, let's see, to the nearest foot. That gives me about 76.4, so we're going to say 76 feet from the base of the tower. Now our next problem is asking us to use one of those new area formulas that we learned for our triangles where we maybe don't know the height. But you can see here we know that two sides are 9 and 15, and then the angle that's included between them is 51. So my formulas that I had it involved triangle ABC, right? We had area equals 1/2 AB sine C, or 1/2 BC sine A, or we had 1/2 AC sine B. But if we think about our triangle where we would be using this, it's obviously called triangle ABC with sides A, B, and C like this. Each one of these formulas is basically saying take 1/2 times two sides, A and B maybe in the first one, times the sine of the angle that's between them, AB sine C. The second one is B and C sine A, and the third one is A and C sine B. So we can see we have one of those situations here. We have two sides and that angle between them. So it doesn't matter which one we think about that we're using here. Each one of these is taking 1/2 times two sides multiplied times the sine of the angle that's in between them. So for our problem over here with triangle JKL, we can say that the area is going to equal 1/2 times 9 times 15, the two sides multiplied together, times the sine of that 51-degree angle. And now all we do is grab our calculator and type this in. So I'm going to type in 0.5 instead of 1/2 because it's just a little bit easier, times 9 times 15 times sine 51. Just typing all that in my calculator, and I'm going to get about 52.5 square units. And so that's what I have for this problem. Again, just using one of those new formulas, and it doesn't matter that this is not called triangle ABC if we just wrap our head around what each of these formulas is saying. Again, it's saying take half of two of your sides multiplied together times the sine of the angle that's between those two sides. Now in this problem, again, we're going to use one of those formulas, but you can see we don't have one of the angles. We have all three sides. So if we found angle P, or angle Q, or angle R, we should be able to use that formula, because then we would have two sides and the angle between. If we found angle R, we'd use side 10, the 10 length side, the 8 length side, and angle P, or we could use the side 4 and the side that's 10 and angle Q. But we need to find one of those angles. Thankfully, we know about the law of cosines, and the law of cosines can help us find one of these angles by using all three side lengths. So let's quickly write out our law of cosines. A squared equals b squared plus c squared minus 2bc times the cosine of angle A. And let's use this to find, it doesn't technically really matter which one I'm going to find. So I'll go ahead and just to make maybe some of these numbers, well, I guess I'm going to end up using all three. I'll just put, I'll find angle R, right? And if I'm going to find angle R, the R is going to go there, which means that this side that I start with is the side across from the R. So my law of cosines is going to say 10 squared equals 8 squared plus 4 squared minus 2 times 8 times 4 times the cosine of angle R. Now I know since I'm using law of cosines to find an angle, the last thing I'm going to do when I get down around here is I'm going to be doing the cosine inverse of something. Now I just need to get to where I'm figuring out what I'm taking the cosine inverse of, and that involves a lot of simplification of all this stuff. So let's go ahead and do that now. 10 squared will be 100, 8 squared will be 64, 4 squared will be 16. 2 times 8 times 4 is going to give me 64 cosine R. So that'll say 100 equals 64 plus 16 is going to give me 80 minus 64 cosine r. Now remember, we can't do this 80 minus 64 right here. That wouldn't be violating the order of operations. So instead, I'm going to subtract 80 from each side, and that's going to give me 20 equals negative 64 cosine r. Then I'm going to divide by negative 64, just trying to isolate the cosine part. So it says cosine r equals negative 20 over 64. Again, I could simplify that, but I'm not going to worry about it because I don't really need to for this problem, because I know the next step is I'm going to take the cosine inverse of both sides. And that's going to leave r by itself, and it's going to give me cosine inverse of negative 20 over 64. Now, some of you might be worried that this is going to be a negative number here. That's okay. What ends up happening, you might have figured this out by now, is that if I do the cosine inverse of a negative number, I always get an obtuse angle measurement, which actually kind of fits here, right? This angle does look obtuse if this picture is drawn to scale. It's at least definitely going to be the biggest angle on this triangle because it's across from the biggest side. So that might be something we would expect to see happening, that we have a negative value inside this cosine inverse function that we're about to do. In any case, I'm going to do cosine inverse of negative 20 divided by 64. And that gives me about 108.2. So r is about 108.2. And I'm going to keep it as 108.2. I'm not going to round it to 108 because this way I'm going to have a more accurate answer here. So that's 108.2 degrees. Now we'll go to find the actual area of this shape. So my area is going to be 1/2. Now, since I'm using this angle, I'm going to multiply these two sides that make that angle together. So it's going to be 1/2 of 8 times 4 times the sine of that 108.2 degree angle. And again, now I'm kind of doing some calculator work. So I'll type 0.5 times 8 times 4 times sine 108.2, and it's going to give me an area of about 15.2 units squared.